Hello guys, and welcome to the first bonus video for the Node Editor tutorial series. My name is Paul from blenderfree.com, and today in this video we are going to tackle the missing feature, which is reconnecting of the edges. So if you hold down the Ctrl key and click on an existing socket, we can reconnect the existing edge to any different socket. As you can see, it's pretty nice. Anyways, we will be also talking a little bit about the architecture, but if you want to know more information about that, I suggest you to go and check out the architecture overview video. However, you should be able to implement it in most frameworks if you are using some different node editor. All of the links to the codes, etc. are going to be as usual in the description. So I hope you are excited, and let's start coding. So first of all, let's briefly talk about the architecture here, since I wanted to make this video more accessible for other people who haven't followed the series or do have their own implementation of the node editor or do want to extend some kind of existing one. So let's just open some files so we can have something to talk about here. So what you can see here is the MDI child window. Inside of this child window, we do instantiate the Q graphic view. The Q graphic view in our case is located here in this file, node graphic view, this one. So let me jump to the top here and open up the list here. So what you can notice is that we actually in the constructor have one most important variable called self mode, since the mode is actual state of our state machine. In the graphic view, we did implement the state machine. We can jump between these modes, so mode no operation, edge drag, and edge cut, and we are going to extend that one with a new state called edges rerouting. So let's have a look how it looks like. Here currently the operation is no operation, and if I do click on some socket and start dragging, I switched to a new mode called mode edge drag, and when I release on an empty space, I do cancel that mode and I go back to no operation. So in this case, we can just simply extend by creating a new state. So if we have a closer look how this graphic view is implemented or the state machine, we are basically handling the basic events like drag enter or drop event or mouse press event and the mouse release event. The mouse press is pretty simple. It just asks which button was pressed and calls the respective method for that one. So most of the logic here is implemented in the left, right, or middle mouse button press and release. And if we have a look here, you can see that the left mouse button press is accessing or getting the item which we clicked on by the event passing in here. And we are just asking if, for example, the item is instance of QDM graphic socket, which in our case is the graphic item representing the socket in the scene. According to the mode, we are doing different branches of this logic. And as you can see here, for example, if the mode was no operation and we clicked on a socket, then the mode is being set to edge drag. And in the self-dragging, we call the method called edge drag start. And we are passing in the item itself. So this is the other thing which is here implemented. Since I wanted to keep the business logic of the state machine as simple as possible and as much readable as possible, most of the functionality is actually stored in separate classes like this one, the edge dragging. The edge dragging is located here in node edge dragging, and it's basically a simple class which contains just a reference for the graphical view, which is here, bunch of variables. This one do not need to be initialized here. However, they are used somewhere in the class below. So therefore, we are just saying here in the constructor, the self-drag edge is none. for the other people to know that actually this class uses something like drag edge or drag start socket and so on. But the most important functions here you can find is edge drag start and edge drag end, where we are passing the item which we clicked on. That one could be the Q graphic item or maybe just the socket directly and so on and so on. So it makes sense to create just a new class for the implementation of the edge rerouting. And let's just call that class edge rerouting. And we are gonna store that in a new file called edge rerouting. Here we can just create a new class, edge rerouting, define the constructor, store the reference for the graphical view, and just to ease our life a little bit, since we are writing a bunch of debug statements in the console, we can create a new constant and call that debug underscore rerouting. And by default, I'm gonna set this one to true. We can create a new method called print. And instead of using just print, we can use self-print. And in our case, we want to pass as many arguments as we want. And if actually the debug rerouting is true, then we are going to print rerouting and pass in all of our arguments we set here. The two most important methods will be start rerouting, where we are going to pass our socket. And for now, just print that we entered this state, and also the stop rerouting, where we are going to pass target, and that's going to be also socket, but it can also be none. We can actually go ahead also here in the start rerouting and store where we actually clicked or started the rerouting. Start underscore socket equals to socket. I'm gonna take this one, copy it to the constructor. By default, that's gonna be none. That means that here in the stop rerouting, we can just say there was no change if the target was equal to self start underscore socket. Otherwise, we are gonna print nothing. And to be able to know if our code is actually working, we need to go to the node graphic view and implement it somewhere. So let me check the init first. We got the rerouting, edge rerouting, everything was found, that's perfect. Let's go to the left mouse button, press button, and let's have a look how this one is being written. So basically we are checking if the mode is edge dragging or something else. We clicked on empty space, for example, and here is a branch if the item we clicked on is the QDM graphic socket, which means we clicked on a socket. That one is just perfect for us, and this one is taking care about the mode edge drag. So we can just extend this code here, and we can ask if self mode was actually also equal to mode no operation, but with our event modifiers and qt.control is true. That means that we clicked on a socket, the previous mode was no operation, and we were holding down the control key, which is going to be the trigger for us to start the rerouting. Then in our item, we are going to retrieve the QDM graphic socket. In this implementation of the node editor, the QDM graphic socket is the Q graphic item, which got a reference to the socket itself. So we can retrieve the actual socket class just by saying item.socket. In this case, we don't need any other check, since if we clicked on QDM graphic socket, we will always have the socket reference stored there. Another feature our socket class contains is a method called hasAnyEdge. So here we can just check if the actual socket we clicked on does have any edge. And if that's the case, then we will set the mode to be mode edges rerouting. And we can call self rerouting dot start rerouting and pass in the socket. In this case, we are gonna end this method here, since we don't want to check for anything else below here. And this should be all of the necessary code for us to start or enter the mode edge rerouting. And we need to also leave it. So that's gonna happen when we release the left mouse button. So in our case, we are checking if the mode is mode edge drag, and if there is some distance between click and release off, then we are ending the edge drag end. Also, similar thing applies to the cutting. At the end, we should set up the mode to no operation. So we can just go here below the mode edge drag. We can add another condition here. If the self mode was actually mode edges rerouting, we can stop the rerouting itself. So we can say self.rerouting.stop rerouting, and our target is going to be item.hopefully the socket. But in this point, in this method here, we are just not checking what the item actually is. So it can be any graphic item. So this could fail. Therefore, we are going to ask for the item.socket only if this instance, this actual item of the class QDM graphics socket. Otherwise, we are gonna pass none, which effectively means that we are gonna pass in this stop rerouting only a socket class if we clicked on one. Otherwise, we are always gonna pass none. That means if we clicked on empty space or another node or some edge. And at the end, we shouldn't forget also to end up the rerouting mode itself. So let's try to run the application once again. If I do hold down Ctrl key and click on this socket, we started the rerouting on some socket. Now we are still in the rerouting mode, and I'm holding the Ctrl key. And when I release the left mouse button on any place, we stopped rerouting on none. So if I click Ctrl key and release it on the same thing, we got no change. And if I do that on a different socket, we stopped rerouting on, as you can see, a different socket, since these two IDs are a little bit different. So we successfully extended our state machine with a new state. So first thing we can do when we start rerouting is we are going to hide our affected edges. So that means all of the edges which are leading to the start socket itself. After that, when we are canceling, for example, we do want to show them up again. So for that, it would be really neat to have a function, let's call that getAffectedEdges. We are just going to ask if the start socket is none. In that case, we are going to return empty list. Otherwise, we are going to access our edges stored in the starting socket, and we are going to retrieve a copy of that list. We are using copy here since it's much safer if you want to play with the edges, like removing them a little bit later. And as the next thing, we can create a set affected edges visible and pass in true or false if we need to show or hide our affected edges. So for that, we are going to for each edge in the self.getAffectedEdges, and according to the visibility, we are going to call show or hide method or the respective QGraphicItem class representing our edge. In our case, we do have in our edge class the GREdge, which is an instance of the QGraphicItem in our scene. Now in our start rerouting, we can just check out if the code is working by printing the number of edges and also setting the affected edges visibility to false. When we hide our old existing edges, the only thing left is to create the new ones to represent our rerouting edges. So therefore, we can go through each of the edge in the affected edges, and we can create a new instance of the edge class. We do know that every single edge is going to start or end in our self.startSocket. And to retrieve our other socket, we can use the edge method called getOtherSocket, where we pass in the known socket and we will get the other one. To create a new edge, we are gonna call the self.getEdge class, and this one is just a shortcut for our self-grview grScene.scene getEdge class. In the scene, it's this method which determines which class should be used for the edge. We will pass in parameters such as the scene reference and also the edge type, which is going to be the same as the old edge. Then we can easily set the starting socket, which is going to be the end of the old one, and we are going to set the new source and the destination position. Also, we are going to update it. Our destination position is going to start where we clicked, and it needs to be updated where our mouse is going to be moving. Because we don't need to recalculate the starting position for every single edge, we can just calculate it once before we enter the for loop. I also do want to keep track of the rerouting edges I created. For this purpose, let's go to the init and create self-rerouting edges equal to empty list. So at the end of the start rerouting, in the for loop, I can just say self-rerouting edges.append this new edge. So let's test it out. I got rerouting edges, obviously, but they are not moving. The way how the edge and the graphical edge are implemented in this node editor is either you can set the start socket and the end socket, or you can set your own source and destination. And once you do that, you need to update their scene position manually. For that, let's create a new method and call that update scene position. Let's call the update scene position only if this actual state is rerouting. For that, we can just simply create a new flag and store that also in the constructor. And also, we are gonna enable it in the start rerouting. To update the scene position, we are going to go through each edge in the self-rerouting edges. And just to be sure, we are going to check if the current gr edge is present in the edge, and also if the edge is not none or something else. This is just to be sure that we are actually working with existing edges which are currently added into the scene. Otherwise, we could run into the exception, which would cause the application to crash. If everything is fine, we can just say edge gr edge set destination to the new location, and we can update. Good place to update our scene position of our rerouting edges would be again in the node graphic view, and for that we can have a look. We can find mouse move event, which is located here, and as you can see, we are already checking here if the mode edge is drag. So if the current state of the state machine is dragging an edge, we are calling self-dragging.update destination, since we want to update the actual dragging edge, the dashed line edge, with our current scene position, or let's say the current mouse position. Just to be sure we are not gonna run into any issues later, let's put every update here into try except block. Now we can easily extend these conditions here, and we can ask if our self mode of the state machine is mode edge rerouting, and we can call the rerouting.update scene position. Time to test it out. And now, as you can see, we are successfully dragging these rerouting edges. If I end up the mode, we stopped rerouting on none, but everything kept the same. In order to fix that, we need to finish our stop rerouting method here. So basically, here is what we are going to do. If our target is going to be none, or it's going to be the same as a starting socket, we are going to cancel everything what's happening. So we are going to set the affected edges visibility to be true. In another case, if we clicked actually new socket, let's just print out that we did, and also set the affected edges to be visible again. Either way, at the end, we should hide the drag edges or the rerouting edges. And for that, let's create a new method and call that clear rerouting edges. At the end, we should also store a new history stamp, and that's gonna be done by self.startSocket.node.scene.history, store history. In the case of the nodeeditor, the history is a separate class stored in the scene, and we can store a new history stamp for the undo and redo. And we should also reset our variables used in this class. The clear rerouting method is pretty simple. We are just going to retrieve every single edge in our rerouting edges list, and we try to remove that. So let's move this method somewhere else, probably somewhere after the set affected method. And also we do need to create the method called reset rerouting. So let's test that if it's working. And as you can see, we successfully returned the edges where they were and also deleted the dragging edges or the rerouting edges. Even here in the console, you can see that we should reconnect from one socket to a different one. I want to briefly talk about the bug I was struggling with for 4 or 5 months in trying to fix that. Obviously, when you are trying to delete certain elements from the scene, which in this case were the dragging edges or the rerouting edges, when we do that in the function called clear rerouting edges, when you remove them from scene, Python actually did said that these elements were for sure deleted. However, they stayed in the scene and it caused crashes. It crashed a lot. So after a few months of digging in the Qt code, trying to understand how it actually works, I also find a bug reports, several bug reports according to this issue, which has been reported in the 4.7 version and also in the 4.8, 5.5, 5.7, and I could add to the list 5.12, 13, and 14, since nobody actually fixed that stuff from the developers. So the solution is to set item index method in your graphics scene to no index. By default, Qt uses BSP3 to sort out the scene elements and to draw them in certain order. However, there is a bug. So once you start to remove multiple elements, like for example in our case was the edge, they remained in the scene and they were not deleted in the C++ side, and they stayed somewhere hidden as a memory leak probably. And this caused crashes, and you are not able to fix that or catch them with try except the blocks in Python itself. So in the second bug report, you can see crash after delete QGraphics item in a QGraphics scene. And it's basically the same thing I was struggling with for months. So luckily somebody at least found some kind of a solution, even though it could mean that your viewport or the graphic view is gonna render a little bit slower. It looks like the Qt developers don't care about this at all, since it's still unresolved. Nobody has given their priority and they just don't care about this stuff. Instead of that, there are new technologies like QML and some other super special languages and QSS styles, which is broken CSS. I don't know. Hopefully you won't encounter this bug. If you do, you can just set the scene indexing to be none and disable the BSP3, which is not working properly. Even though I wasn't able to reproduce this bug right now when I'm recording this video, it is still there and it was mostly seen on Windows 7 system. So no guarantees that that's not gonna happen in Windows 10 also, or the other system like macOS and so on. So if you do struggle with not disappearing elements or randomly crashing when you are trying to delete stuff, just make sure you do have disabled in the node graphics scene the indexing. And to finish the rerouting logic and functionality, let's add a few code. So first of all, I'm adding a check if start socket is not none to disable or set, no, actually disable the highlighting on the starting socket. And also we do want to collect all of the affected nodes when we successfully reroute the edges. So here, just instead of a simple print, we are going to go through each of the affected edges and we are going to retrieve the nodes connected on both sides of the edges. And if the node is not yet being added to this list, the affected nodes, we are going to add it. Then we are going to check if our target is input socket, and if it is, that means that we going to remove all of the edges which were connected to that socket. And then we need to just decide to which end of the edge we are going to connect or set the target itself. After that, we can just update edge positions. And it's time to test the code. And as you can see, I can reconnect that to a different socket, which means it works. Last thing to finish up the stop rerouting is to send the notifications to all nodes which have been influenced by the rerouting of the edges. So we are going to go through all of the affected nodes and we are always going to trigger on edge connection changed event. And then we are going to check for the start socket and also for the end socket if they are in inputs of the node, and if they are, we are going to trigger on input changed for the node. And I almost forgot that I already did implement the edge validators. So basically, these are functions which you can register directly into the edge class with calling register edge validator. It's a function which takes an input socket and output socket and it decides and returns true or false if such an edge would be valid or invalid. So for example, here is a cannot connect two inputs or two outputs, and it basically checks if the input and output, both of these sockets are output sockets, is going to return false. The same it does when both of them are inputs, which means you cannot connect two inputs together or two outputs together. So to use them, you just need to do this once, somewhere where your application starts or after it starts. And if you want to have a look on working example, you can check out the examples calculator. It already uses that, so you will find that in the repository. Talking about the validators, we can go back to the edge rerouting here. And first of all, before doing anything else, we are going to check if the edges would be or wouldn't be valid. So first of all, we are going to create valid edges and invalid edges. First one is going to be initialized with our list, and the second one is going to be empty list. And then for each and every single edge, we will retrieve the starting socket, since the other one we already have, and we will run the edge.validate edge with those two sockets, and if they are true or valid, we are going to leave them, otherwise let's append them to the invalid edges. And then go through all of the invalid edges and remove them from the list. And to the rest of the code, we are going to use the valid edges. So if I test it now, and as you can see, I can reconnect these to the input. However, if I try to reconnect that to the output, it gets returned back, since that is not possible. And I do see validating here, and I should see this edge rerouting is not valid, which is perfect. So the validation actually works. And so far we did implement it. the logic or the rerouting exactly like Unreal Engine does it. So let's create a trigger or a constant which we can control if we do want to have the rerouting working like in Unreal, or if we want to be a little bit more consistent with the node editor and how it's working so far. So we can go to the left mouse button release, where was our code, and in the case if we want to do rerouting like in Unreal, we can just use what we had. The version 2 would be a little bit different. So we will check if we actually clicked with the mouse button already. And if we didn't, we are going to ignore the rest of the code. So let's create a flag. The flag is going to be called first mouse button release. By default, it's going to be false, and also we do want to reset that rerouting. If we go back, we can just skip, and at the end, we should call exactly the same stop rerouting. However, there is a little bit more clever way how to write it, so let's just invert the if and just check if the first mouse button was released. Set the flag, and then always trigger the one single line of the code. Now, time to check if that is working. So I can click and release, and as I can see, I can drag around, and I can reconnect that to the same socket. If I do that again, you can see that the edge actually swapped back where it was, since we do have a validator which don't allow us to connect the output and input of the same node. So let's check if the Unreal Engine is still working. Open up the test scene, and again, I'm dragging, and once I release, it snaps back. I can't do this one. However, I can connect them together, and this swaps back again. Perfect. So that means it works. I hope this episode was useful for you. And if you got any questions, leave a comment. Don't forget to subscribe. Or you can support me on my Patreon page. The special shout out goes for Evan Atherton, Audrey Bashan, and I thank you very much, guys, for your support. So I hope you liked the video, and see you next time.